Good afternoon, everyone. Let's start our session on data science interview questions. Our first question is, what are the 5 popular algorithms of machine learning? So the answer is decision trees, neural networks, probabilistic networks, nearest neighbor, and support vector machine. Next question. What are the 3 stages build the hypothesis or model in a machine learning? Oh, sorry. 3 stages of building the hypothesis or model in machine learning. They are model building, model testing, and applying the model. These are the 3 stages. What is the standard approach to supervised learning? The standard approach to supervised learning is to split the set of example into training and test. What is training set and test set? In various areas of information science like machine learning, a set of data is used to discover the potentially predictive relationship known as targeting set. Training set. Training set is an example given to the learner, while test set is used to test the accuracy of the hypothesis generated by the learner. And it is a set of example held back from the learners. Training set are distinct from the test set. List down various approaches for machine learning. The different approaches in machine learning are concept versus classification learning, symbolic versus statistical learning, inductive versus analytical learning. What is not machine learning? Artificial intelligence and rule-based intelligence are not machine learning. Explain what is the function of unsupervised learning. Find clusters of the data, find low dimensional representations of the data, find interesting directions in the data, interesting coordinates and correlations, find novel observations. What is the difference between artificial learning and machine learning? Designing and developing algorithms according to the behaviors based on empirical data are known as machine learning. While artificial intelligence, in addition to machine learning, it also covers other aspects like knowledge representation, natural language processing, planning, robotics, etc. What is classifier in machine learning? A classifier in a machine learning is a system that inputs a vector of discrete or continuous feature values and outputs a single discrete value, the class. What are the advantages of naive Bayes? In naive Bayes classification, it will converge quicker than discriminative models like logistic regression. So you need less training data. The main advantage is that it can't learn interactions between features. What is model selection in machine learning? The process of selecting models among different mathematical models which are used to describe the same dataset is known as model selection. Model selection is applied to the fields of statistics, machine learning, and data mining. What is Perceptron? In machine learning, Perceptron is an algorithm for supervised classification of the input into one of several possible non-binary outputs. What is ensemble learning? To solve a particular computational program, multiple models such as classifiers or experts are strategically generated and combined. This process is known as ensemble learning. Why ensemble learning is used? Ensemble learning is used to improve the classification, prediction, function, function approximation, etc. of a model. When to use ensemble learning? Ensemble learning is used when you build component classifiers that are more accurate and independent than each other. What is variance decomposition of classification error in ensemble method? The expected error of a learning algorithm can be decomposed into bias and variance. A bias term measures how closely the average classifier produced by the learning algorithm matches the target function. The variance term measures how much the learning algorithm's prediction fluctuates for different training sets. What is an incremental learning algorithm in Ensemble? Incremental learning method is the ability of an algorithm to learn from new data that may be available after classifier has already been generated from already available dataset. What is dimension reduction in machine learning? In machine learning and statistic, dimension reduction is a process of reducing the number of random variables under consideration and can be divided into feature selection and feature extraction. What are support vector machines? Support vector machines are supervised learning algorithms used for classification and regression analysis. Do you think 50 small decision trees are better than a large one? So that means, is random forest better than decision tree? Yes, because a random forest is an ensemble method that takes many weak decision trees to make a strong learner. Random trees or random forests are more accurate, more robust, and less prone to overfitting compared to small decision trees. Why is mean square error bad measure of model performance? Mean squared error gives a relatively high weight to large errors. Therefore, mean square error tends to put too much emphasis on large deviations. A more robust alternative will be mean absolute deviation. What are the assumptions required for linear regression? The assumptions are the sample data used to fit the model is representative of the population. The relationship between x and the mean of y is linear. The variance of the residual is the same for any value of x. Observations are independent of each other. For any value of x, y is normally distributed. Extreme violations of these assumptions will make the results redundant. Small violations of these assumptions will result in a greater bias or variance of the estimate. How to remove multi-collinearity? Multi-collinearity exists when an independent variable is highly correlated with another independent variable in a multiple regression equation. This can be problematic because it undermines the statistical significance of an independent variable. You could use the variance inflation factor to determine if there is any multicollinearity between independent variables. A standard benchmark is that if the VIF is greater than 5, then multicollinearity exists. How to check if the regression model fits the data well? There are a couple of metrics that you can use. R squared, relative measure of fit. This was explained with the multicollinearity. F1 square evaluates the null hypothesis that all regression coefficients are equal to 0 versus the alternative hypothesis that at least one doesn't equal 0. RMSE, absolute measure of fit. What is What is a decision tree? Decision trees are a popular model used in operations research, strategic planning, and machine learning. Decision trees will have nodes and they will have the branches and a root. The last node of the decision tree where a decision is made are called the leaves of the tree. Decision trees are intuitive and easy to build but fall short when it comes to accuracy. Is it beneficial to perform dimensionality reduction before fitting an SVM? When the number of features is greater than the number of observations, then performing dimensionality reduction will generally improve the SVM. What is overfitting? Overfitting is an error where the model fits the data too well, resulting in a model with high variance and low bias. As a consequence, an overfit model will inaccurately predict new data points, even though it has a high accuracy on the training data. What is boosting? Boosting is an ensemble method to improve a model by reducing its bias and variance. So ultimately converting weak learners to strong learners. The general idea is to train a weak learner and sequentially iterate and improve the model by learning from the previous learner. is mean imputation of missing data acceptable? Mean imputation is the practice of replacing null values in a data set with the mean of the data. Mean imputation is generally bad practice because it does not take into account feature correlation. For example, imagine we have a table showing age and fitness score, and imagine that an 80-year-old has a missing fitness score. If we took the average fitness score from an age range of 15 to 80, then the 80-year-old will appear to have much higher fitness score than he actually should. Second, mean imputation reduces the variance of the data and increases bias in our data. This leads to the less accurate model and a narrower confidence interval due to a smaller variance. How do you handle missing data? There are several ways to handle missing data. Delete rows with missing data, mean median mode imputation, assigning a unique value, predicting the missing values, using an algorithm which supports missing value like random forest. The best method is to delete rows with missing data as it ensures that no bias or variance is added or removed and ultimately results in a robust and accurate model. However, this is only recommended if there is a lot of data to start with and the percentage of missing values is low. Give examples of data that does not have a Gaussian distribution nor log normal. Any type of categorical data won't have a Gaussian distribution or log normal distribution. Exponential distributions. The amount of time that a car battery lasts or the amount of time until an earthquake occurs. Give an example where median is better measure than mean. Median is a better measure than mean when there are outliers in the data. How, how will you calculate sensitivity of machine learning models? In machine learning, sensitivity is used for validating the accuracy of a classifier, such as logistic random forest in SVM. It is also known as recall or true positive read. Sensitivity can be defined as the ratio of predicted true values and total events. Sensitivity is equal to true positives by positives in actual dependent variable. True events are those events that were true as predicted by a machine learning model. The best sensitivity is 1 and the worst sensitivity is 0. Compare overfitting and underfitting. In order to make reliable predictions on general untrained data in machine learning and statistics, it is required to fit a model to a set of trained data. Overfitting and underfitting are the two of the most common modeling errors that occur while doing so. A statistical model suffering from overfitting describes some random error or noise in place of the underlying relationship. When the underfitting occurs, a statistical model or machine algorithm fails in capturing the underlying trend of the data. When a statistical model or machine learning algorithm is excessively complex, it can result in overfitting. Underfitting occurs when trying to fit a linear model to non-linear data. Although both overfitting and underfitting yield poor predictive performances, the way in which each of them does is so different. While the overfitting model overreacts to minor fluctuations in the training data, the underfit model underreacts to even bigger fluctuations. Role of data cleaning in data analysis. Data cleaning can be a daunting task due to the fact that with the increase in the number of data sources, the time required for cleaning the data increases at an exponential rate. This is due to the vast volume of data generated by additional sources. Also, data cleaning can solely take up to 80% of the total time required for carrying out a data analysis task. There are several reasons for using data cleaning in data analysis. Two of the most important are cleaning data from different sources help in transforming the data into a format that is easy to work with. Data cleaning increases the accuracy of a machine learning model. Explain eigenvectors and eigen okay. Explain eigenvectors and eigenvalues. Eigenvectors help in understanding linear transformations. They are calculated typically for a correlation or covariance matrix in data analysis. In other words, eigenvectors are those directions along which some particular linear transformation acts by compressing, flipping, or stretching. Eigenvalues can be understood either as the strengths of the transformation in the direction of the eigenvectors or the factors by which the compression happens. Can you compare the validation set with test set? A validation set is a part of the training set used for parameter selection as well as for avoiding overfit of the machine learning model being developed. On the contrary, a test set is meant for evaluating or testing the performance of the trained machine learning model. What do you understand by linear regression and logistic regression? Linear regression is a form of statistical technique in which the score of some variable y is predicted on the basis of score of a second variable x, referred to as a predictive variable. The y variable is known as the criterion variable. Logistic regression is a statistical technique for predicting the binary outcome from a linear combination of predictor variables. Explain recommender system. Recommender system is a subclass of information filtering system meant for predicting the preferences or rating awarded by a user to some product. An application of a recommender system is the product recommendation selection in Amazon. This selection contains items based on the user search history and past orders. Could you explain how to define the number of clusters in a clustering algorithm? The primary objective of clustering is to group together similar identities in such a way that while entities within a group are similar to each other, the groups remain different from one another. Generally, the within sum of squares is used for explaining the homogeneity within a cluster. For defining the number of clusters in a cluster algorithm, within sum of squares is plotted for a range pertaining to the number of clusters. The resultant graph is known as elbow curve. The elbow graph contains a point that represents the point post in which there aren't any decrements in the within sum of square. This is known as the bending point and represents k in k-means. Although the mentioned widely used approach. Another important approach is the hierarchical clustering. In this approach, dendrograms are created first and then distinct groups are identified from here. What do you understand by deep learning? Deep learning is a paradigm of machine learning that displays a great degree of analogy with the functioning of the human brain. It is a neural network method based on convolution neural networks. Deep learning has a wide array of uses ranging from social network filtering to medical image analysis and speech recognition. Explain gradient descent. The degree of change in the output of a function relating to the changes made to the input is known as gradient. It measures the change in all weights with respect to the change in error. A gradient can also be comprehended as the slope of a function. Gradient descent refers to escalating down the bottom of a valley. Simply consider this something as opposed to climbing up a hill. It is a minimization algorithm meant for minimizing a given activation function. What are vanishing gradients? The exploding gradients are a condition when the errors grow at an exponential rate or high rate during the training. This error gradient accumulates and results in applying large updates to the neural network, causes an overflow, and results in inane values. What are hyperparameters? Hyperparameter is a kind of parameter whose value is set before the learning process so that the network training requirements can be identified and the structure of the network can be improved. This process includes recognizing the hidden units, learning rate, epochs, and various other associated. What are the differences between deep learning and machine learning? Differences between deep learning and machine learning. Deep learning gives computers the ability to learn without being explicitly programmed. Machine learning gives computers a limited to unlimited ability wherein nothing major can be done without getting programmed. And many things can be done without the prior programming. It includes supervised, unsupervised, and reinforcement machine learning processes. Deep learning is a subcomponent of machine learning that is concerned with algorithms that are inspired by the structure and function of the human brain, called artificial neural network. Machine learning includes deep learning as one of its components. What are the different kinds of ensemble learning? The different kinds of ensemble learning includes the following: bagging and boosting. Bagging implements simple learners on one small population and takes mean for estimation purposes. Boosting adjusts the weight of the observation and thereby classifies the population in different sets before the outcome prediction is made. So that was the last questions of today's session. Thank you.